All right, I'm going to switch gears because the first half of the book does definitely impress you with how little we know, even though it starts with all these guys in the 1880s saying, we know everything, it's all over, the end of science, we're fine. And then you read and you read and you think, we know less, we know less, we know less. And then we get to the subject of life, and then you turn sort of buoyant in this book. I'm not sure why, but let's go do it. The question here is, why is there life?
Buoyant. Life is a
and
buoyant.
then are we alone? So let's just do this in order. Why do you think there are living things? There is absolutely no necessity for dust to aggregate and become vital, not less, let alone think. Do we know why we have life? I guess not. But
Why? Allow me to address that.
yes.
If you look at the chemical ingredients of life itself, you remember from biology class, we're mostly water. And good old water is H2O, 2 hydrogens, 1 oxygen. And if you could look at the sort of the element budget of life, hydrogen is number 1, as expressed in the water molecule. The number 2 in the human body is oxygen, turns out. Number 3 in the human body is carbon. 4 is nitrogen. 5, you find on all lists, is other. Okay, now if you go to the universe, that's the O on the periodic table. You didn't know that? That's not for oxygen, it's for other. So you go into the universe, number 1 ingredient in the universe is hydrogen. That was true in life. Number 2 ingredient in the universe is helium. We don't have that one.
It doesn't like
But
anybody.
now, how come? Well, because helium is chemically inert. You can't do anything with it even if you wanted. You can inhale it, okay? And sound like Mickey Mouse, yes. Next in the universe is oxygen. Next, carbon. Next, other. Thank you, in the 3rd row there. So, actually that was the 2nd row. They must be related to the 2nd row here. We are 1-for-1 matchup with the most abundant ingredients in the universe. Of these, carbon is the most chemically fertile element in the entire periodic table. You can make more kinds of molecules with carbon than all other molecules combined. So, if you were going to experiment through the forces of nature with complex chemistry, and you had to pick an element to base it on, carbon is your man. Or your woman, however that goes. Okay, so what I'm saying is, given what carbon is capable of doing, perhaps we shouldn't be so surprised that there's life, because we are carbon-based life. We're just another one of the things carbon has rolled up its sleeve. Maybe life is inevitable, given the abundance of carbon and oxygen and nitrogen and hydrogen in the universe. Try to invert that view. Otherwise, you're left thinking, hey, we're special. You know I would give you right to say you're special? If life on Earth were made of an isotope of bismuth. That stuff is nowhere in the cosmos, and then we're made of it, we're special. Okay? But if we're the most common ingredients of the matter that we know and love, you don't have an argument.
Well,
Let
me just make sure I understand what you're saying. I don't know that everybody in this room or everyone in the world would think that life is merely an aggregate of the right chemicals in the right order, all holding hands in the right way. You get your carbon, you get your oxygen, you get your nitrogen, you get your hydrogen, and you put it all in the right way, and bing, up comes a little cell, and then you get a bigger thing, and then you get a fish, and then you get a you. It may be. Is that your view? That the world is pregnant with life because all life is a chemical machine arranged in some lucky way. You don't even like the word lucky. In some...
Yeah, was the guy lucky over here?
Yeah, never mind.
Okay. I thought we got through that.
Yeah, okay, we did. Is that right? That's your view?
I'd rather say it a different way.
Okay.
I'd rather say that given the chemical fertility of carbon and the abundance of all the ingredients in the universe that is fundamental to life as we know it, I'm not given any reason to doubt that the formation of life from out of chemical soups brewing either in our solar system or across the galaxy or the cosmos itself, I'm not given reason to believe that that should be a rare phenomenon.
Your friends of life in the book are, you like liquid, because liquid just seems to slosh
Life
things.
as we know it.
Life as we know it, sorry. Carbon, I guess planets with hard surfaces would be good, something like a rock occasionally. I mean, maybe you could have
I don't know. We just recently learned that most of the biomass of life on Earth is probably living beneath Earth's surface, in the nooks and cracks and crannies of Earth's crust, where the number of ways and places to live vastly exceeds the number of niches that exist on Earth's surface.
At least they're rocks. I mean,
what I'm saying is, to say you need a surface, I don't know that you need a surface.
I just maybe, if you're going to be in Saturn, you're just kind of dealing with a cloud. Maybe you could grow in a cloud, but at least if you have a rock or something.
Wait. Do fish care that there's a surface? No, because they're swimming through a liquid. They're swimming through a fluid. They don't care. Fish don't go down to the ground and hang out unless you're a catfish. Okay? They're swimming. So why can't there be swimming life in the atmosphere, in the gaseous atmospheres of the Jovian planets? There's nothing in principle that should prevent that any more than life swimming in the ocean is prevented just because you think we need a surface to live on.